Marine macroalgae or seaweeds are primitive groups of plants that are lacking true roots, stems and leaves. They belong to three different groups on the basis of thallus color. Brown algae, phylum Ochrophyta, red algae, phylum Rhodophyta, and green algae, phylum Chlorophyta. Red and brown algae are almost exclusively marine, while green algae are common in fresh water like rivers, lakes, and even in terrestrial dwelling akin to rocks, walls, houses, and tree bark.
Green seaweed contains green pigment, chlorophyll, which absorbs the light maximally. The red seaweed, which lies below the sea or at the depth of the water, contain red pigment phycobilin along with chlorophyll pigment. The red pigment overshadows the green pigment and helps in the absorption of light even at low depths. Whereas the brown seaweed, which contain the pigment fucoxanthin, helps along with the chlorophyll to absorb the light when the brown seaweed is covered with water. Most of the seaweeds we found in the coast of India are green seaweeds represented by Caulerpa cactodis, Ulva fasciata, Ulva intestinalis, Ulva lactuca. And the red seaweeds are represented by Gracilaria corticata, Gracilaria edulis, Gracilaria verrucosa, Gracilaria gracilis, Gracilaria multipartite, Gelidium corneum. And the brown seaweed contains Sargassum wityi, Sargassum polysystem, Sargassum tenerimum, Sargassum vulgare, Sargassum muticum, Turbonaria ornate, Turbonaria turbinata.
Seaweeds have been cited as early as 2,500 years ago in Chinese literature. Many countries, including India, started utilizing this neglected renewable marine resource.
Cultivating the seas is not something new because people around the world have been doing it for centuries. In fact, it's even done in India, in parts of Tamil Nadu and Gujarat.
Seaweeds are fast emerging as a viable alternative for ensuring food and nutritional security.
Growing these seaweeds are not as hard as it sounds because you just put it into water, let it stay there for 30 to 45 days, no more inputs. It's got the seawater and the sun it needs, and then it just grows. Simple as that.
Seaweeds most exploited for culture include the brown algae, followed by the red algae and a small amount of green algae. China holds the first rank in production of all the above three categories, followed by North and South Korea, Japan, Philippines, Chile, Norway, Indonesia, USA, and India. Seaweeds are grown abundantly along the Tamil Nadu and Gujarat coasts and around Lakshadweep and Andaman and Nicobar Islands. Rich seaweed beds are found around Mumbai, Ratnagiri, Goa, Karwar, Varkala, Vizhinjam and Pulicat in Tamil Nadu and Chilka in Orissa. The film looks into the collection and processing of agar and alginates along the coasts of Tamil Nadu, particularly the coast of Ramanathapuram district. Here the seaweed is collected both from the waters off the mainland coast and those surrounding the chain of offshore islands.
So what you're seeing is the seaweed culture. You can see the bamboo raft floating in the sea. And these bamboo raft contains nylon ropes, almost 10 to 15 ropes connected. To each rope, a small bit of seaweed is attached, and then they are allowed to hang. And below this you can see a net which prevents the predators to eat on the seaweeds. This will take nearly 15 days to harvest a small piece of seaweeds. So in this bamboo raft, you can collect nearly 2 to 3 kilograms of seaweed. So this seaweed is called Capophysis. This is an exotic species, not belong to India, brought from other countries. And then this is mainly cultured just to make a liquid fertilizer out of this seaweed, where the fertilizer is used to, for the growth of the plantation crops. So this is the harvested seaweed from the rafts after 40 days of culture. This each weighs around 8 kilograms, can grow up to 20 kilograms. Now they are harvesting it, and then part of the seaweed, again, they are using as a seaweed that the woman is doing as a seaweed. This is the seed which they will tie to the raft. Again it will start growing, and then after 40 days they will harvest like this.
For the people in the coastal villages, fishing is their main income and seaweed collection is an important second source of income. For the women who are otherwise not actively employed in fishing, seaweed collection may be their only income. Hand-picking of seaweed is normally carried out by women equipped with divers' masks and a net bag. Harvesting of agarophytes is done through inshore collection during low tide on the shores of neighboring islands and by diving from boats when the seaweed is further out.
First, Anna Paliamana, அடுத்து வாரையில ஊருக்கு ஒரு வாரம் கழிச்சு வந்துருவோம்.
எவ்வளவு ஆழத்துல போய் இத எடுப்பீங்க?
தலை மறைய போவோம்.
தலை மறைய. 10 அடி ஆழம் போவீங்க.
போவோம். போய் நீஞ்சிட்டு அல்லன்னு பாசியே.
ஒரு தடவை போனீங்கன்னா எவ்வளவு
மொத்தமா எல்லாரும் சேர்ந்தோம்டா 100 இல்ல 150 சேருவோம்.
ஒரு கிலோ எவ்வளவு தூப்பீங்க?
ஒரு கிலோ 15 ரூபாய்.
15 ரூபாய். Here what you are seeing is, after collecting from the sea, the seaweeds are dried. They are separated. The women folks who collected the seaweeds from the sea are now separating them and then spread them in the sand for drying purpose. Then they will, after drying, they will separate the both seaweeds. Now you can see the people are sorting out two types of seaweeds. One is green seaweed, another one is red seaweed. And then this is get dried here partly, and then it is sold to the big companies for extraction of alginic acid and for further processing.
Red and brown seaweeds collected from the small buyers in and around Rameshwaram and other coastal areas were transported to the industry for large-scale production of sodium alginate, alginic acid, carrageenan, agar, etc.
Now this is Kappa ficus or Euchuma cottoni, which is a cultivated seaweed, and we make carrageenan from this.
Now I am going to extract carrageenan from this red seaweed, Kappa ficus alvaraceae powder. 10 gram of red seaweed powder is taken. To this, add 500 ml of distilled water and kept in stirrer at 90 degrees Celsius for 2 hours. After 2 hours of stirring, it is then filtered. This is seaweed material. This is the carrageenan extract. Equal volume of ethanol is added to precipitate the carrageenan. This is the final product, then it is dried and made into powder.
Carrageenans are generally employed for their physical functions in gelation in foods like ice cream, viscous behavior and stabilization. They are also used in lipsticks, soaps, film, paint, varnish and buttons.
Now this is Sargassum which we collect from natural beds, this particular one. Now alginate is produced from this.
I am going to extract sodium alginate. For this 20 gram of seaweed sample is taken and it is soaked in 2% formaldehyde solution. This is 2% of formaldehyde solution. Then it is mixed well. It is incubated at room temperature for 24 hours. It is filtered to remove that filtrate. After this process, the seaweed material is taken for further experiment. Then 0.2 molar HCl is added. Then it is mixed well and incubated at room temperature for 24 hours. After 24 hours, then it is filtered. To this, add 2% sodium carbonate. Incubated at room temperature for 24 hours. After 24 hours of incubation, then it is filtered. After sodium carbonate extraction, the solution is more viscous. Add 2.5% sodium hypochlorite for bleaching. Then it is dried in hot air oven at 60 degrees Celsius. Final product, sodium alginate in powder form.
This is sodium alginate food grade with FSSAI license. I think you can see it here, on that. Okay, this is a food grade. This is as per Bureau of Indian Standards. This goes in all as a food additive in ice creams, tomato ketchup and various food items. The next one is potassium alginate. Now, this is again another salt of alginate, but this essentially goes in food, but it can also has a lot of industrial application like welding electrode. The other one is ammonium alginate, the third bag. Now, that is essentially going for rubber latex creaming. So that's for a different sort of an industry. The fourth is sodium alginate just industrial grade. Now, when we come next, we come to Algae Cream. Now that's a blend of our products which is used as an ice cream stabilizer, which we sell to the ice cream manufacturers. The next is Peg Gel. Actually, this is Carignan, which we manufacture. We sell it under a trade name called Peg Gel. And this is calcium alginate, once again an alginate which is used for welding electrode mainly. It can also be used in bandages as a wound healing and all that. They use it in bandages. This is alginic acid. Essentially, it's mainly used by the drug industry for disintegrating tablets, like even Crocin Advance uses this material, and antacids like Gaviscon and all buy from us. Reflux, Gaviscon buy from us. So these are the various grades of alginate and peg gel and blends we make.
Agar-agar, agar-rose and carrageenan are commercially valuable substances extracted from red seaweeds. Agar is used extensively in food preparation and in the pharmaceutical industry as a laxative or as an outer cover of capsules. This industry has a lot of byproducts. Nothing goes waste in the seaweed industry. The effluent of seaweed industry containing high acidity 2 to 3 pH is further processed and brought to normal pH 6 to 7 by treating with algae and aeration, so that this treated effluent is mixed with the waste product of seaweed after extraction of products.
It's a very slow process. It takes 18 months more or less to biodegrade and compost the material. And we get a beautiful manure, which you can see right here. The first sample is the manure. Now we also produce from this with some special technology that we have developed, where we make what's called as a gel, which is again organic certified. And this is the gel, and this is our gel which we sell. And it is used. Now, 1 can of that gel is enough for 1 acre, and the studies show it can increase yields of about 20 to 30%. The second can is what we call as plankton, O6 plankton. This is used for fish feed. This comes from our phycoremediation plant, the biomass. Now, this is something which we have now introduced because most of the farming is going to switch to drip irrigation. So this is actually O6 drip, as we call this. Can be just mixed and used with the drip. It will not choke the nozzles, nothing. It will just beautifully disperse and go away. And again, it is organic certified. This is again we call organic 6. It's a foliage spray which you can dissolve in water and spray on top of plants, as a foliage spray. So these are the various products we produce in our agriculture division, which is utilizing seaweed and is highly effective, increases yields, reduces pest control.
Seaweed has got a potential to get nutrient from the water, and mostly it has been shown that 80 to 90% of the nitrogen and phosphorus can be taken from the most polluted area when you are cultivating the seaweed, which need not be for human use, because if you are using for human consumption, you have to select a particular site of importance where there won't be much contamination. So once you are using for industrial purpose, you can very well use even the contaminated water which can take the nutrient, and that nutrient can be utilized for the cultivation of the horticultural or even the paddy product as a biofertilizer. And recently we have carried out some experiment with the biofertilizer from the seaweed biofertilizer for the horticultural crops like tomato, with some ladies involved in Odisha coast, and they have been awarded in one of the function in Puri, and it was very successful, and we are getting lot of demand from the paddy cultivars that you provide us the biofertilizer from seaweed.
The nutritional value of seaweeds is undisputed. They are rich in minerals, vitamins, trace elements and bioactive substances. Sea vegetables for human consumption constitute about 83% of production, while the remainder is used as fertilizers and animal feed additives, medical applications and biotechnical applications.
Take these seaweeds and convert it into a renewable resource. a renewable resource which could, be biofuels, which could fuel your cars for tomorrow. It could be renewable plastics, renewable chemicals. It could go into animal feed. It already goes into food ingredients. I mean, it is almost like a magic resource which has so many different uses, and what we like to call it is a biorefinery, in which you could take seaweed in and extract all sorts of products from it without leaving a single drop. What these products are, that is the future. There are so many of them right now, but there's still so much work to be done and so much more value which can be extracted from the seaweeds.
Seaweeds offer the potential to help meet nutrition and food security needs, and also hold other advantages in medicine and farming. Seaweeds contribute to the national economy by supplying materials to the market that would otherwise need to be imported. It is also important in providing income opportunities to many fishing communities, particularly the women.